Okay, so I started out by defining that rate equals 378 over time, because 378 is our distance, rate equals distance over time. And since our goal is to find r, I also wanted to establish that we know the rate plus 9, because they're going 9 miles an hour faster, is equal to 378 over time minus 1, since we know it took 1 less hour. So when you have that, then you can make this nifty little equation by basically multiplying both sides by r plus 9 and then dividing by 378. So it moves over like this, and basically reforming it as distance equals rate times time. And then you can substitute so that you know that if you replace 378 with rate times time and then divide by time, you'll have r equals r plus 9 quantity times t minus 1 quantity over t. And then rate times time equals r plus 9 times the quantity time minus 1. So then we can also replace the r with 378 over time, which gives you this disgusting looking thing. The t's cancel out, so 378 equals 378 over t plus 9 quantity times the quantity t minus 1. And then we do some simplification. Here I just cross-multiplied out the terms, like FOIL and stuff. And then I subtracted 378 from both sides to make it 0 equals 378 over t plus 9t minus 9. Moved over the 9. And then divided the entire equation by 9. So 1 equals 42 over t plus t. Then I made it 1 minus t equals 42 over t. Then you can multiply the t on both sides. So you have t times the quantity 1 minus t equals 42, which I did some algebra to kind of rewrite that. But when you solve the t minus t squared, or negative 1 times the quantity of t squared minus t equals negative 42 equation, then you end up with basically two different answers, because that's a quadratic. The other is negative 6, which negative 6 doesn't make sense for a time because time can't be negative. So the other is a positive 7. Because it's positive 7, then we take 378 equals 7 times the rate, divide both sides by 7, and you get 54.